We need to hold that down. Okay, so with division, we remember dangerous monkeys swipe bananas, which gives us our steps: divide, multiply, subtract, bring down, and repeat. So let's do 1080 divided by 6. Dividend divisor. First we divide. Can I divide 1 into 6? No. Can I divide 6 into 10?
Yes.
One time. So that's my divide. Check there. So now we're going to multiply. 1 times 6 is 6. Check there. Now subtracting. 10 minus 6 is 4. And then I bring down my 8. No, you're just sitting and you're listening. This is just a quick review for your quiz. So all eyes should be on the screen. Now we brought down, now we go to repeat, which brings us right back to divide, and I divide where I left off at. 6 goes into 48 8 times. So I place that 8 above the number that I brought down. Check for divide again. Multiply. 8 times 6 is 48. Check that. Subtract. 48 minus 48 is 0. However, check on subtract. I still have to bring down the 0. 6 can be divided into 0 times. Okay? So I just divided. Now I multiply 0 times 6 is 0. Divide. Now I subtract 0 from 0 is 0. There's no bring down. There's no need to repeat. My answer is 180. That's your standard algorithm for division. Okay? Now let's talk about factors versus multiples. This is key for you remembering if I ask for GCF or LCM, which one I'm talking about. So let's look at the factors of 6. I could do a prime factorization tree, which we'll do next, but I'm just going to do a list. Factors are the numbers that are going to make up 6 that I can multiply together. 1 is always going to be in there because of 1 times 6. 2 is in there because of 2 times 3. And I'm going in order counting up from 1 up so I don't miss anything. 3 is going to be in there because 3 times 2 gives us 6. Not 4, not 5, but 6. Now let's look at same number, but we're going to look at, multiples. Let me bring it up for you. Multiples of 6. Multiples are meant to be multiplied. I'm going to list those. So if I do 6 times 1, I get a multiple of 6. 6 times 2, I get a multiple of 12. 6 times 3,
18.
Multiple of 18. 6 times 4, multiple of 24. 6 times 5,
30.
okay, and on and on and on. Now we see the difference. Factors are the numbers that are multiplied together to get to the number 6. Also, factors can be called divisors because these numbers can evenly be divided among the number 6. Multiples are meant to be multiplied. So this number 6, I do my multiplication tables and go through 6 times 1, 6 times 2, 6 times 3, 6 times 4, so on and so forth to infinity, okay? So we covered the difference between factors and multiples. Now let's look more at factors. We're going to do prime factorization, also called a factor tree, but the one reason that is called prime factorization is because you're doing that factor tree until you get to all prime factors. And remember, we circle our prime factors. So what if I do
84.
Okay, we could do 84. So I know that multiples of 84, and even if I don't know, what I can simply do is say to myself, hey, can 84 be divided by 2? I think it can. You will have to do this skill called multi-digit division if you don't exactly know. So 2 can divide into 8 4 times, multiply, giving me 8, subtract, 8 minus 8 is 0. Now I bring down, now I have 2. Yes, because 2 times 4 is 8. So 8 minus 0 is 0.
About the 82.
You made
It's 84.
82. It's supposed to be 84.
Oops, it's okay. Let me change that. Thank you for the call out. So now I'm bringing down 4. That's why we use a pencil, but I have to use a pen so you all can see. So let's start over. 84 divided by 2. 2 still goes into 8 4 times. That's still true. Subtract or multiply 4 times 2 is 8. Subtract 8 minus 8 is 0. Now I brought down the 4.
8 minus 4. 2 times 2 equals 4, and you put the 4 on top of it in the ones place.
Well, right now we're back to, we repeated. We already divided, multiplied, subtracted. We brought down, now it's repeat. Back to divide. 4 divided by 2 is,
2.
so I put my 2 above my 4. Multiply, 2 times 2 is 4. 4 minus 4 is 0. So the answer is 42. So going back to my prime factorization, I have 2 times 42 as my factor so far. Is this prime?
Yes.
Because I only have one factor pair. Our 1 and 2 are my factor pairs. That's it. So I circled that. 42, however, I know 6 times 7 is 42. So I got my tree there, and I know 7 is prime because only one factor pair, 7 times 1. Now I handle this 6, which is 2 and 3. Both prime also. The way you'll see your answer when you're asked, what is the prime factorization?
So it's a factory.
Hold on. Of 6, or of 84. Because that's our big number, is 84. The way you'll see your answer is 2 ways. Expand it with your prime numbers, meaning 2 times 2 times 3 times 7. If we multiply that to check it, 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is 84. So we did it right. That is the answer when it asks what is the prime factorization of 84. All prime numbers that the product is 84. Okay? Now let's look at this is not for my enjoyment or I know how to do this. You have to show me if you can do this. So I suggest you get the review. Now let's look at GCF, which stands for greatest common factor. You have to have at least 2 numbers, but you can have 3. So let's do 6, 8,
Bathroom break.
and 48. We'll come back after the bathroom break. So again, I know we took our bathroom break, but we're back. We're on our greatest common factor. Have a seat, DP, so I can. Greatest common factor of 6, 8, and 48. As long as you have 2 numbers to compare, you can find the GCF. Please know that GCF is the same thing as greatest common divisor because factors are numbers that can evenly divide your big number. So if I look at the factors of 6, 1 is always in there. 2 is in there, 2 times 3. 3 is in there, 3 times 2. And so is 6. Okay? Now looking at 8. 1 is always in there. 1 times 8. 2 is in there. 2 times 4. We need to focus. 3 is not in there. 4 is in there. 4 times 2. And 8. 48. Again, 1 is always a factor of a number. 2 is in there. 2 times 24. Is 3 in there?
No.
4.
Let's just make sure. 3 times 48. You never know. That would be 3 divided into 4 is 1. Multiply, giving me 3.
Yes.
4 minus 1, or 4 minus 3 is 1. Bring down your 8. Repeat. Divide now. 18, or 3 divided into 18 is 6. 6 times 3 is 18. 18 minus 18 is 0. Nothing to bring down. That's why you always want to check. You know how to divide, so check. So 3 is in there. 4 is in there because of 4 times 12. Not 5. 6 is in there. Not 7. 8 is in there, correct. Not 9, 10, not 10, not 11. 12 is in there. Not 13, 14, or 15. 16 is in there. And then 48. Now it's time to circle our common factors. What do all three have in common? Well, they have the 1, they have the 2. No 3. 4 is not up here. Nope. That is it. So let's look. I'm going to show you. 3 is here, 3 is not here, 3 is here. That's not a common factor. It has to be in all 3. 6 is here, 6 is not here, 6 is here. Not a common factor. Now it's time to look for the greatest. So out of these 3 numbers, if I look just at what I circled, their common factors, I see that 2 is going to be my GCF, also known as greatest common factor, also known as greatest common divisor. So if you see that, that's just GCF. That concludes your review.